Okay, so the idea now is to try to understand the difference between a mutex and a semaphore. The big idea of both is to limit the availability of a section of code or somewhere in the process to other um, processes that needs the something that we want to save or something we want to define. For example, for mutex, we can say that mutex inhibit the entering of different processes to a critical section. So using mutex like closing the availability of a critical section to other processes as long as a process running the critical section. This let us know that no two processes will run the critical section and there won't be any problems with the critical section. So you can see here what's going on with a mutex. It's like a lock. I mean, each process gets to the mutex, then make the status of the mutex as locked. You can see it right over here. And it becomes the owner of the mutex. Each process that gets in becomes the owner of the mutex, and the meaning of this ownership is that only this process that is currently inside can unlock the mutex and let the next process get inside and use, for example, the critical section that the mutex uh, guarding on. Now, the idea of semaphore is more like it bounding the number of processes that can get inside to a somewhere that we want in the, for example, in the code, and only the number of capacity that the semaphore can accept can get inside. You can see that there is a capacity, and we calculate how many processes inside. And when a process gets inside, it send a message that called wait to the semaphore, decreasing the number of capacity he has left. So we cannot get to more than 5 processes at a time in this section. And when a process gets out, namely exit, he just say the semaphore, he signal the semaphore, he do a signal command that tells the semaphore that they can increase its free spaces. You can see here the free spaces. Each time the process gets out, the free spaces again get up, and when a process gets inside, the free spaces gets down. So you can see the difference. There is no ownership here for the semaphore. You can see that different processes that get inside can change the semaphore. Here in the mutex, we have like a binary, more like a binary semaphore, but with the ownership of the process that inside that only he can change and open the semaphore. He is the owner. This is a little bit about the difference between the semaphore, which is the capacity, different processes. I can change the capacity. Now it's only two. This is the semaphore. It's counting like a lock. And the mutex, which is like a binary lock. Only one thread may own the lock at a time, and here multiple permits allow concurrent entries. And both can be used in operating system depending on what you want. Do you want that many processes can get inside? If there is a critical section you get and you let some process get inside, there may be a problem, because if some of them will run the critical section concurrently, there may be problems. In the mutex, you know that only one, it's a binary, only one process can get inside and it's owner of the lock, so only he can release this lock. So it depends on what we want to do and which type of lock we want, counting or like a binary more with ownership. But this is the core difference between a semaphore and a mutex. Both are, let's call that, a type of locks, but with different use cases. And this is it. Thank you very much. There is also some explanation of this, let's call it animation. You can see how they call signal and permit and how they lock and unlock but I think that the explanation I gave is quite enough. Thank you very much. This was about the difference between semaphore and a mutex, and that's it.